have been considering life on the Earth, and the reason for that is if we want to eventually think about life elsewhere in the universe, we should first look at all the different instances of life that we are aware of and see if they all have something in common. So, even though we are only considering life on one planet, we notice that life seems to possess some degree of complexity. You will have certain atoms bonding to form molecules, and those molecules will be engaging in chemical reactions. If life requires some degree of complexity to it, then you need some complicated molecules like those amino acids and proteins that we saw earlier. This is a very strong reason why we believe carbon is very often going to be a necessary ingredient for life. Unlike many other atoms, carbon can bond to up to 4 other atoms, so carbon can form these really complicated molecules that would allow life to possess some degree of complexity to it. This is not to say all life in the universe will necessarily be based on carbon, but we expect the majority of life to be based on carbon. Also, carbon bonds strongly, not so strongly that its bonds can never be broken, but it also doesn't bond so weakly that its bonds are easily broken. Carbon is also fairly common compared to many other substances. Similarly, we made arguments for why we think liquid water is necessary for life. There is a lot of water in the universe in the context of water vapor or water ice, but we notice all life on Earth depends on liquid water. So even though when we think of life on Earth, we think of sea level, temperature, air pressure, the type of environment that we interact with all the time, life has been discovered in some other extreme environments on Earth, such as miles underground where you have no sunlight and a really high pressure. Life has been discovered in scalding hot springs where the temperature is really, really high, like in Yellowstone National Park. Life has been discovered on the bottom of the ocean floor where the sunlight cannot reach. Life has been discovered under ice-covered lakes in Antarctica, and life has also been discovered in highly acidic or alkali environments. Now, most forms of life on Earth would not be able to survive in these conditions, but we have discovered some species of plants and animals and other forms of life that do thrive here, and these organisms are referred to as extremophiles. If we say life needs to be based on carbon and life needs to possess some degree of complexity to it, that means you're going to need to take these carbon atoms and be able to build up really complicated molecules with them, kind of like those proteins and amino acids we saw earlier in this course. In a very highly acidic environment, for example, these acids would tend to just break down these really complicated molecules. So if you're going to have these really complicated molecules, they need to be somehow protected from these acidic environments. And this also applies to, for example, really hot temperatures, really high pressures. There's no reason we expect life on other planets to resemble life on Earth, but if we're going to say life on other planets will need to have some type of complicated chemistry, that chemistry needs to be able to occur, then we expect that life on other planets should have a way of protecting that chemistry so it can proceed and life can happen. So looking at some of these extremophiles possibly is one way to get an idea of what some forms of life on other worlds might be like. And again, this is not to say life on other worlds will necessarily resemble extremophiles on Earth, but it kind of gives us an idea of how life might behave in other environments that are not similar to the comfortable environment that we are used to. So where else might we look in the solar system to find life? Could we find life on the moon or Mercury? The moon and Mercury are very similar bodies, so I'm going to group them together. Well, we said life depends on liquid water, and any liquid water on either of these bodies will boil away into space right away. Life probably needs some type of liquid. You need a medium for facilitating the transport of nutrients and waste. You also need a medium for your chemical reactions to take place. Liquid water has a lot of other nice properties like a high heat capacity that we talked about earlier in this course. So there is no liquid water on the surface of either of these worlds. There is ice on these worlds in craters, but that's not good enough. You need liquid water as far as we know. Also, the lack of an atmosphere is an issue. If you're going to have life, that life probably needs a relatively stable environment. But because both the moon and Mercury lack an atmosphere, you have extreme temperature swings. When you are on the day side of this world, the temperature will be really, really hot. And when you are on the night side of the world, the temperature is really, really cold. And we're talking swings of 1,000 degrees Fahrenheit for Mercury between day side and night side, swings of 400 or 500 degrees Fahrenheit for the day side and night side of the moon. And so you don't really want these giant temperature swings if you need a more stable environment, most likely if you're going to have life. Also, these bodies do not have any substantial atmosphere. So UV radiation comes from the sun. On Earth, the ozone layer is able to block UV radiation, but UV radiation from the sun just comes down and strikes the surface of these worlds. Now, UV is a high energy color of light, so UV light will just break apart complex biological molecules. And if you're breaking apart these complex molecules, you're probably not going to be able to have these molecules combine to form life. Also, there isn't really much liquid water, it is believed, under the surface of the moon. If you think about how the moon was formed in the big splash when a Mars-sized object collided with the early Earth, spewed a lot of debris, which eventually collected to form the moon. If there were liquid water, or if there were water in that debris cloud, that water would just escape away into space as the moon is forming. There is some degree of ice on the moon, but there really is not many volatiles in the moon or Mercury's surface. So this is not to say that there is definitely not life on these worlds, but we think it is very, very unlikely that there is life on either of these worlds. What about life on the giant Jovian worlds like Jupiter, Saturn, and the ice giants Uranus and Neptune? Well, similarly, it is not expected that there is going to be life on either of these worlds. The environment of these worlds is believed to be very adverse to life ever beginning. Now, again, this is not to say it is impossible for life to begin on these worlds. It's just that we think it's very highly unlikely that life will exist on these worlds. So watch Carl Sagan's video Cosmos Life on Jupiter that's linked to in the YouTube playlist for more on this, on what life might be like. And if you think about the very first lecture from this course, in an infinitely large universe, you would certainly come across a few Jovian-like worlds where life has managed to develop. But without a solid surface, it is probably highly unlikely that life exists on Jupiter in our solar system. Venus originally resembled Earth very much. Venus probably in the very early solar system did have some degree of liquid water on its surface. Venus's early atmosphere resembled Earth's early atmosphere. Venus is also a similar size to Earth. But the Earth and the Venus then took two very different paths. Venus eventually had its runaway greenhouse effect, where the surface is now hot enough to melt the metal lead, 850 degrees Fahrenheit on the surface. You have 90 atmospheric pressure times the atmospheric pressure of Earth on Venus's surface. You have a sulfuric acid haze. So the surface of Venus probably does not have any life on it. The really high temperatures will tend to break apart these biological molecules, so that would not be very good for life. The sulfuric acid in Venus's atmosphere, well, you could imagine there are extremophiles on Earth. There possibly could be life forms on Venus that could get around living in a very acidic environment. However, up high in Venus's atmosphere, high above the surface, it is possible some simple life forms might exist. So at an altitude of about 50 kilometers above the surface of Venus, the temperature is very modest. The temperature is comparable to the Earth temperatures at sea level, around, say, 60 degrees Fahrenheit. And the pressure, the air pressure there is about 1 atmospheric air pressure. You still need to get around the fact that you would be living in this sulfuric acid haze. But as we said, there are extremophiles on Earth that are able to withstand an acidic environment. So it is not impossible that if some primitive life forms evolved on Venus early on in the planet's history before the runaway greenhouse effect began, and then that life might have spread out, and as the runaway greenhouse effect took over, that life might have adapted, and there might still be some ancestors of that early life in the upper reaches of Venus's atmosphere. Again, this is not a sure thing. There is no strong evidence that such life forms exist, but it is an interesting possibility to consider. If of all the places in the solar system that might harbor life, Mars is probably going to be the most probable place to find a living organism on it other than Earth. So we know that life requires liquid water for reasons we discussed, and we know there is liquid water underground on Mars. Now, there is no liquid water on the surface of Mars. Mars's air pressure on the surface is so low that any liquid water that might well up to the surface immediately boils away due to the low air pressure. But underground, we know there is liquid water on Mars, and also, even though Mars has no ozone layer and the UV radiation, just like the problem with the Moon and Mercury, the UV light will just hit the surface of Mars and break up and damage living organisms. Underground, living organisms would be shielded from that UV radiation. So, on the other hand, Mars's soil is fairly inhospitable to life as we know it for Earth-like life forms like bacteria. There's a large amount of hydrogen peroxide in the soil. That chemical would tend to oxidize very readily and destroy living organic material. Percolates are another nasty chemical that is found in the Martian soil. So there might be life on Mars, or there might not. But this is a very interesting possibility. There may be life on Mars that has found a way to adapt to these problems. So as of right now, we really do not know. So if life adapted to these conditions, and remember, life does require some really complex chemistry, but that would be a phenomenally interesting discovery. What about life on the icy moons in the outer solar system? So you have Europa and Enceladus, both have really large subsurface oceans of liquid water on them. These moons orbit around their planet. Europa orbits around Jupiter, Enceladus orbits around Saturn. And as these moons orbit the planet, tidal forces stretch and squeeze the moon, and these tidal forces then will create friction in the moon, and this friction heats up the interior of the moon and acts as a source of energy to keep the interior ocean liquid. So this is a very interesting possibility for the existence of life elsewhere in the solar system. Now, the icy crust of these moons is several miles thick, so you have some degree of protection from cosmic rays, other ionizing radiation, basically the light and radiation that would come in and destroy the biological molecules. So there are plans in the works for probes to investigate Europa specifically. Europa Clipper, to be launched in the coming years, is going to plan to fly through some of these plumes of water that are ejected by the moon and see what's in them. Eventually, there is going to be a lander on Europa, possibly with some type of submarine attached. Would be a very interesting experiment to go, if it could go through the ice, swim around, see what's in the ocean. That would be a really exciting science experiment to conduct. Saturn's moon Titan is another phenomenally interesting science target for the purpose of learning about life elsewhere in the solar system. There are two worlds in the solar system that have continuously flowing liquid on their surface. Earth has continuously flowing water on the surface. Titan has continuously flowing hydrocarbons on the surface. On Earth, we have a water cycle where water evaporates into the atmosphere, forms clouds, rains down, collects in rivers, lakes, groundwater, all that stuff. Titan has a similar cycle on its surface, but instead, Titan has a methane cycle. So you have these lakes and rivers of hydrocarbons. Literally, you have lakes of liquid natural gas. Titan is believed to somewhat resemble conditions on Earth when the Earth was really, really young, shortly after formation, except Titan is incredibly cold, something like negative 240 whatever degrees below zero. So Titan is an incredibly cold world. It took a very different path from what the early Earth was like. There has been one probe that landed on Titan. It snapped one picture. Why only one picture? I do not know. When the Cassini spacecraft flew to Saturn about a decade ago, the Cassini spacecraft carried the Huygens lander that went down through Titan's atmosphere, landed. It snapped this one picture that these rocks in these picture are about 10 centimeters across. So put your two fists together. That's about the size of the rocks in the foreground. And over time, as Cassini was orbiting Saturn and the Saturn's moons, it observed liquid ebbing and flowing over Titan, coming and going at different points in the year. So Titan is a very interesting science target to consider life. Now, as I've tried to emphasize before, we believe we could make some statements about what life may be like, but at the same time, we don't want to say life must necessarily resemble life on Earth. So on Titan, any life that is there would probably be based on these liquid hydrocarbons rather than liquid water. Now, water has a really high heat capacity. That is something going for it that these liquid hydrocarbons would not necessarily have, but it is possible that life found a way around that issue. In addition, Titan has a really cold environment, so what would that mean for the prospects of life? Well, any living organism living in a super cold environment would probably have a really slow metabolism. So we are much warmer compared to any potential life form on Titan, so we're going to move around fast, eat a lot more often, use up our energy more often. On Titan, where it's much colder, these organisms might have a really slow metabolism. They would be very slow in their life cycle and all the things that they do. So what if there is something like some weird plant on Titan that resembles a rock? If you found life on Titan, how would you be able to distinguish it as actually something that is alive versus some type of rock? If its metabolism is so slow, if the rate at which it interacts with its environment is so slow, it might be really difficult to just identify something as a living organism on a world like this. But Titan itself is a phenomenally interesting science target for looking at life somewhere else in the solar system. So watch the Carl Sagan Life on Jupiter video, watch the video by Kurzgesagt, Life on Rogue Planets, and then I will see you in the next video.